Okay. Yes. You have all the slides? Because I saw 3 decks from Dropbox. Yes, okay.
Come on, you're in a total.
Mentally, I didn't have the cycles to do anything about them. So I just was going to do it right now if we had a problem. We don't want that open.
Have you given Stephanie a hard time about giving you back-to-back sessions all freaking day?
I know, all 3. Yeah. I couldn't believe it. No, I haven't given her crap, but I will. There are only 3 slots. I'm chairing all 3. It's like, that's mean. So thank you for getting those uploaded this morning. Sure.
Usually more aggressive about
Yes.
This time.
Okay, it's time. Okay, at the time it's time to begin. If we could take seats and get started, please. Alexa, could you close the door? Thank you. All right, so the first thing, as always, is the note well. Eric, can we have one meeting, please? Thank you. So the blue sheets are already going around. Please make sure you sign in. And here is the agenda that was posted on the mail list. We didn't get any bashing there. Do we have any bashing here? Okay. Guess we'll begin.
All right, we'll start with a quick update on the status of the 3 documents that are with the ISG. They are all in a position of discuss clearing. I don't believe we have any issues there that require coming back and talking to the working group. Folks have hopefully been following what's been going on. John, do you have some stuff you want to check?
I think the only thing I'd want to talk to the working group about is probably in certs. Is the specifically Stephen had kind of a large issues list on that. Most of those I think we can work through pretty simply. The one that probably will result in, I imagine, a directional change in certs relates to the OCSP environment for this. And for those of you who have not been following the home game, and this fortunately these days all get CC'd to the list. Stephen was concerned about the per pass implications of using OCSP for validation for telephone numbers, because effectively relying parties that were using OCSP for real-time validation, because of this, the certificate extensions that we incorporated into the document would effectively be sending over the wire, hey, is this cert valid for this number or not? And be getting back, yeah. And unfortunately, OCSP is in the clear, right? And so like anybody from a per pass perspective could be like listening in on that. And there are a bunch of things I think we can do to address that. I think, though, the likely consequence of that that would require at least the working group to not have an objection is probably we will, I think, roll back the strength of the recommendation for that mechanism at this stage and say, look, there are a couple of things we're going to experiment with. Sean wrote a great section of certs that kind of goes through, here's the possible things you could do for the design space of kind of more real-time validation of this, including short-lived certs versus OCSP. What we might kind of do, and we'll get into this a bit when I talk about Stir with Acme, is look at some of these short-lived certs strategies for this. And so we may end up kind of punting this, I guess is what I'm trying to say, that the result of this might be the certs document will say, here's some ways we know how to do this, but we're not going to offer the same like recommend for OCSP that we originally did. So is there anybody here who thinks that's a appalling idea and that we shouldn't do that? Because that's my inclination based on, I think, the state of the discussion today.
So I thought there was one other aspect to that, and that was that the security considerations was going to explain, or there was going to be a new privacy consideration section.
So we will definitely have to have the certs document also call out that this specific
Okay.
quality of OCSP.
That's what I thought.
That's what I said in my additional response. My initial response to Stephen was, we will definitely at least call out the issue. I think that's true either way, that we're going to call out the issue. Though, as I've kind of weighed this myself and talked to some other people about it, I think I'd probably also be inclined to just roll back the recommend a bit and instead say, here's some ways to do this. We're still figuring it out a bit. The main thing we want to get out of STIR certs is, again, the TN-auth list extensions that it specifies to create ways we could talk about things like SPIDs and TNs and certs that are sensible. And this real-time validation stuff, again, I think we may have to experiment with a couple strategies before the IETF wants to make a stronger recommendation for one versus the other.
I agree with that, but I think there's also one other aspect to the short-lived certs, which is if they're short-lived enough, you don't need to do any revocation checking. And so we should say that when that's the case, you include the no rev check extension.
Oh, well, okay, sure. So when we're doing that, yeah. So kind of what I'm going to propose, and again, I have a slide about this at the end of the STIR with Acme thing. I think there's something specific we can propose to do on this.
So, I mean, short-lived certs obviously are a viable option for things. I just want to call out that and I think this is why the Acme stuff is important, is that the current OCSP design has a reliance on the OCSP server as an oracle for mapping SPIDs to telephone numbers. And so if you're going to be using, if you're going to map to short-lived search system, you're going to need something like Acme so that you can say, I have a credential to authorize the SPID, and then when I need it, I can go run out and get a cert that validates that TN as opposed to the SPID, because otherwise there's no way to resolve the SPID, right?
Yeah.
Or you need a separate SPID resolution mechanism, right?
Sure, yes. And I think a separate SPID resolution mechanism for SPID to TN stuff, if you're performing that check. And like nothing in these documents says you have to perform that check right now. But I think I was hanging out with Henning a few weeks ago, and he actually like brought up a web page while we're sitting there having this conversation that was like showing you SPIDs for TNs, right? So I mean, I think that's a solvable problem. We can find an oracle that'll do that transformation if relying parties want to do it.
Right. So I guess it would be, I would request that for perhaps people who are not, for the convenience of people who are reviewing this document and are not quite as expert on SS7 as you are, it'd be good if maybe a little bit of layout of what the options were would be.
Okay, before we move to the next topic, we realized we didn't ask for a JabberScribe at the beginning. Is anyone willing to do that? Sean's kind of sitting at that orange thing.
I'm fearful of that.
Are you doing it or not? Okay, thank you, Matt.
So Gene is scribing for us today. Be sure to say your name clearly when you get to the mic.
Thank you.
All right. And John, I've got you set up to control your own slide transitions.
I'm not sure I can be entrusted with this responsibility, but we'll see how it goes. Welcome. It's been a while since we talked about this one. It's been a long time. This feels kind of like thread necromancy. Now that is, of course, because back in the day, when we originally started the STIR work, there was a concept that we wanted to talk about the use of STIR within SIP and then potentially the use of STIR outside of it in other protocols. And initially, I think people who are working in practical deployments today, they will push back and say, we got to do this for SIP first. And thus the charter contains the stipulation you see here that the in-band mechanism must be sent on to the ISG first, and then we will at least be able to propose candidates for the out-of-band mechanism. And to which I say, voila, we have sent on RFC 4474 BIS and Passport and so on to the ISG. And thus, I would like to return our attention a little bit today to out of band. Now, these documents aren't quite done yet. As you just heard, we're still doing fixes, responding to discusses, and I don't want to represent this as something that we're going to start tackling necessarily immediately today, but I have some ideas about how we can start to make a bit of progress on this going forward. And it doesn't even require a recharter. We even have a milestone for this, right? Already in the charter today, though admittedly it's we've fallen a little behind on that one. But let's first take a step back and ask, practically speaking, do we still need this, right? When we started out talking about STIR, obviously we were looking at defeating a set of very specific threats related to robocalling, swatting, voicemail hacking, all of which we believed were enabled by impersonation. And we want to close just this one kind of narrow loophole that enables impersonation today. And this largely exists, again, in these kind of IP to PSTN environments where someone, unfortunately today, can find an IP service that allows them to populate a number arbitrarily, and then some gateway to the PSTN will simply trust that, and that will end up showing up in your caller ID on the PSTN side. So when I ask myself, you know, what we revisited all this for, I mean, that's the R in STIR is revisited. You know, we revisited this because the original RFC 4474 had too strong a focus, I guess, on the greenfield and not enough on these transitional deployments. And it turned out these transitional deployments that have these gateways and so on are where all the pain is, unfortunately, where a lot of the insecurity is currently being exploited. So, I mean, my stipulation anyway is that fixing IP to IP simply isn't enough. Fixing end-to-end STIR stuff isn't enough for a number of reasons. And that we need to do something that is going to address some of these more hybrid use cases, including pure PSTN to PSTN use cases, to make a good dent in the problems that we set out to address here. And fortunately, I think the work we've done has led to the development of some great tools that are extremely well suited to this purpose. And I think we're going to find the solutions for out-of-band look really much more adjacent to the work on in-band than they thought we would have when we started this off. Because, you know, I mean, this kind of goes more into what the limits, I guess, of in-band really are. And I guess there are two crucial limits. One is the gatewaying stuff that I was referring to. And there are a lot of different gatewaying cases. You can't really even anticipate when you throw a call out, you know, in the IP realm, you know it's going to go to a gateway. It could return to the IP realm afterwards. That the fact that the creator of a SIP request won't really know at the start whether or not it's going to go in band all the way end to end is kind of one of the greatest piece of uncertainty, I guess, in the security architecture that we've developed here to date. And, you know, even if it does go IP to IP, there could be some administrative environments where identity headers get stripped. Maybe just because there's legacy equipment there that doesn't support the in-band SIP mechanism, and some of these deployments are quite paranoid, and they'll strip any headers that they don't understand. Or it could be that there's an administrative trust boundary, and there are identity headers that are specific to some trust domain that need to be stripped on the way out of it. And so it's not merely even a gatewaying question. There are even some like IP to IP cases where media will go end to end, but we can't necessarily expect that SIP identity headers will make it end to end. The great thing about this, of course, is Passport. You know, when our discussions about Passport started, and for those of you that weren't following this too closely, Passport came out of work in the ATIS IP NNI group. It kind of recast the signature that we were considering for RFC 4474 BIS into a separate object format. I was kind of pleasantly surprised to contemplate how that kind of an object could be applied, not just to gatewaying to other protocols. If you want to do things like having potentially end-to-end security go through something like Jingle. Here would be an object format that could pass from like a SIP to XMPP gateway and potentially enable end-to-end identity across protocols like that. Or WebRTC is another case. This is something Cullen has been looking at a bit, is how you'd be able to enable these Passport objects effectively to be used in a WebRTC context to, again, enable end-to-end identity across those protocols. But interestingly enough, once you have this object format, which was narrowed down to just this bare minimum that we identified as being the things you absolutely needed anytime you wanted to be able to provide caller ID. Where was the call coming from? Some identifier for the originator. Where's the call going? So when you receive it, you know whether or not it was cut and pasted and sent to you. And a timestamp associated with the call to make sure that you're not being replayed something that's very, very stale. Those elements are so generic, so non-protocol specific, that you could even look at this as a store and forward sort of problem, that if any endpoint that can generate a token like this could just like stick it somewhere, well, that token could be generated or could be retrieved by a relying party who could compare it to a call they just received and potentially trust that identity, just, you know, based on the fact that it conforms with the expectations of those three crucial factors. Really, stir doesn't provide anything better, right? I guess I'd say any attack that could get around that and out of band would also get around that and in band. It's kind of a limit of the assertions that we developed in Passport. And we can talk about timing attacks and very, very clever things people could try to do to exploit this. But it seemed like Passport would be a really good fit for doing the kinds of things we envisioned doing with out of band in the first place. But maybe it'd help to kind of show some use cases to give a sense of where I think this would be useful and how it all fits into the architecture. This is it. This is like a pretty basic triangle model that we developed for out of band really at the start of the Stir working group. We had slides that looked like this when Stir was still a BOF, basically. And it was all based around the concept there'd be something that we call a call placement service. At the time, we called the records that you would store in the CPS, we called them CPRs, call placement records. And so they were, we had like the CPR, we're resuscitating you because this was going to be a fallback mechanism for cases where end-to-end IP wasn't being carried. But we can just imagine that there are smartphones that support Stir, that support the ability to generate Passport objects anyway, that are on two sides of a connection. And it doesn't really matter what goes to the middle. There could be a PSTN, and it could be just a normal POTS call, but provided that the smartphones, and as they're defined here, what I really mean is just any phone that has internet access and enough smarts to like generate and provision a Passport object or to restore it on the other side. They just kind of provision this up to the CPS, and when the rallying party gets the call, they just retrieve it and can use it to get the same validation they would if this had been carried in band end to end. That's the basic idea. It's really not any different from what in-band Stir does, except for the fact that we have this rendezvous layer that just eliminates any obstacles, any protocol interworking, any administrative obstacles that might be in the middle. That's it. That's the basic idea here. And it's crucial to say, when we talk about smartphones here, obviously mobile phones are what we all immediately think of, but I'm also thinking of ATAs that might just be connected up to your triple play in your house, or IPPBXs, right? There are all kinds of entities that have this quality that they can place telephone calls and that they have an internet connection. As long as you have those two qualities, you can participate in an architecture of this form. And all the architectures that we're going to talk about are going to look kind of like that. And they all have the same set of basic questions that are the interesting architecture and design questions about them. One of them, of course, is discovery. Discovery is one of the big ones. Like, okay, that's a pretty picture, but it really does seem to suggest that these two phones, which have no previous association, need to have some mechanism to converge on dealing with the same CPS. And that's a very interesting constraint of the architecture, not a trivial one. Especially not when you consider that Passport objects, for example, could be created by multiple entities associated with a call. We've always stipulated that there could be multiple authorities who would be authorized to sign specifically for the same Passport. And we need to make sure that they come to exactly the same conclusion about that. And this is something we talk about a little bit in the draft. You can look in the fallback draft. Ironically, there are any number of systems that have these qualities that we've talked about in the past, I think are interesting. We've looked at DHTs for this. Sometimes when I squint at this just the right way, not to say a word that's heretical in this room, I'm sure, it starts to look a bit like that Viper thing we talked about years ago. In the sense, I could imagine doing a DHT, for example, that would let you push, at least locate what the proper CPSs were. There are a lot of reasons why Viper didn't work, and I think a lot of them ended up being about the authorization dimension of this, which fortunately we solved because we assume you have these credentials that already tell you I'm the right entity to provision things to this telephone number. And so Viper ran into a whole ton of problems that were concomitant in the fact it didn't have that initial security association at the start of it. But there's a DHT way of looking at this. I could imagine doing DNS ways of looking at this. I could imagine looking at lost, right? Looking at things we've looked at for eCrit. I think we have a lot of options. I'm not sure we need to standardize any particular one of them as the one true way. But I could even imagine within specific deployment environments, there being solutions that would make sense for this you might not use elsewhere. There are some cases where in some of the use cases we'll look at, we can assume some pre-association between, say, gateways that are participating in an architecture like this. But that's one of the obvious design questions you need to solve. Another is, of course, the privacy question. We need to make sure that when we're creating the CPS is not just emitting vast amounts of like per pass relevant data. And more significantly that an attacker cannot interrogate the CPS to ascertain when calls are in progress or to reveal information like that. And so a lot of the tricky things that Becker and I have spent time talking about and thinking about in working on this are about ways to try to get around that. But basically, there are only a number of simple components you need to create a system like this. You need some kind of CPS. They'll let you store and retrieve the passport objects. You need to figure out how to get to it. You need the smart endpoint clients for this. And you need a robust story about privacy. I think all four of those are the qualities that we're showing in the draft today. I think if you've got those four things, though, you pretty much have got this design space in at least properly contextualized. Beyond the case where it's actually the endpoint that initiates the call, which is kind of how we think about the mobile phone case. Another use case we talk about in the draft, I think is an interesting use case, is one where there's one or more gateways who instead are the entities that interact with the CPS. So you can imagine in this case in the far left, ordinary in-band stir is going on. The user agent that is starting that call has gotten their signature from their service provider. There's an identity header and a SIP request they're sending out, and that's about to hit the PSTN. Because the originating user agent did not support any of these kinds of fallback mechanisms, it could be that some gateway before the PSTN ends up being the entity that provisions the passport up to the CPS, where a relying party could eventually find it. I think we want to allow use cases like this, and use cases like this are interesting largely for authorization reasons. I'll talk about that in a bit, about who gets to provision these things and why. But we can show parallel architectures to this for PSTN to IP cases as well, where it ends up being a gateway on the far side that retrieves the passport object that was provisioned by an originating user agent. We can look at a lot of cases that basically look just like tunneling. I mean, unfortunately, we cannot go to the SS7 network, right, and force it to get a passport object stuck into it. There has been work that's going on over in Addis that is looking at ways to say in the PSTN, this gateway received a call from the IP world that was signed by STIR, was signed by Shaken. And that this is an indication that will then be carried through the SS7 network, so that you should trust this the way that you trust STIR. I think having a cryptographic assurance this way will ultimately end up being superior. And there are even use cases, I think, where you kind of want to do both of these options, where you maybe even have an originating user agent that is STIR compliant, or an authentication service as an intermediary that is STIR compliant, that at the time it creates a passport, it both sticks it into an identity header in a SIP request that it sends along and provisions it to the CPS at the same time. Again, anticipating that, because it can't tell, right, whether or not it's going to hit some network boundary or hit a gateway or something like that, that will actually like deprive us of that end-to-end identity information. And that could end up with flows that look like this, where you've got two gateways, right? And this starts in the IP world, and it's going to go through just a few yards of the PSTN in a data center or somewhere along the way. But because that call, when it gets routed to the PSTN, that POTS call, ultimately is going to get routed back out into the IP world, we'd like to be able to recover that initial object. And this is a case, I think, that SS7 indicator probably doesn't handle very well, in the sense of like, this actually gives the end-to-end assurance between the user agents in this case, even if they don't support this out-of-band mechanism, provided the gateways do, that you could never get from simply having an SS7 indicator in the POTS call there that tells you that this was originally signed by STIR. Great to know this was originally signed by STIR, but what I'd like is the original passport, right, that was in this. And this shows a way you could get the original passport at the terminating side of it. There are a lot of hard edges on building cases like that. A lot of this comes down to questions of who's authorized to provision these passport objects and why. I think, the good news is that we can use the security of passport for the most part as the means of authorizing whether or not you should be allowed to provision an object at the CPS. In other words, we can imagine the CPS making the same authorization decision that a relying party does when it looks at a passport object. It doesn't matter to the CPS, in other words, who stores it, whether it's the authentication service that created it or some later entity that is harvesting the passport object from SIP signaling after it's been traveling through the network for a while. Because the decision that the CPS can make about it is simply looking at the passport itself. Is the authority that signed for this the right authority for the originating identity in the passport? And if so, obviously I should store the passport and look at the timestamp. Is this valid? Is this not, from 2 years ago and, obviously invalid? Provided that's true, I think it's pretty clear the passport could just authorize it based on that fact about the passport alone. And in terms of the retrieval part, the questions are very similar. I think that comes down to CPS design to some degree, because we want the relying parties that access the CPS basically to, not to require any previous association with the entities on the other side in order to do so, since we, as I said, can't anticipate where a call will land exactly. So we have some things about CPS design we'll say about that and about ways we can try to make that rendezvous work. But first, Chris?
Yeah, that Chris went. That was the question I was going to ask. Is this? I understand you want to limit writing, but it sounds like you might need to have it a little open from a reading perspective. And the problem with a passport object is it has all the call detail records in it.
So the call detail records in it. So you definitely wouldn't want that just to be shared with anyone. Yeah. So this is the robust privacy design component of the system. So we have a couple things to say about that. One possibility, so a lot of this depends on what your key is for retrieving the CPS. And Matt, do you have a jabber comment?
Yes, Eric Berger states, except for providing an easy point for pervasive metadata monitoring, why do we require CPS instead of an end-to-end transfer for the passport token, where we can use all of the IETF end-to-end integrity mechanisms to, 1, deliver the token, and 2, ensure its integrity?
Well, I mean, obviously this.
Just go back to the whole rationale.
Yes. So Eric, the reason we have this is because this is in cases where there is not an end-to-end IP connection between the authentication service and verification service necessarily. But Jonathan?
Yeah, I mean, slightly less hostily, but similar question. I mean, how do you stop the CPS itself from being a very attractive per-pass target?
Sure. So we're going to start getting into now what the CPS design questions are. And this is the part that requires all the smarts in this, yes. So there are a couple of answers to that. And I guess, so I'm not going to pretend that I have a complete baked solution that we're going to offer up today. I think I'm going to talk about what some of the building blocks for a solution are. But to be clear, I think that there is work to be done in this working group, and this is a large part of what that work is. If you look at this slide, again, right now what we assume is when you connect up to a CPS as a verification service that wants to acquire a passport from it. You've just received a call and you have that originating number. And what you do is you contact the CPS and say, okay, are there any passports from this originating number? That's what's in the document right now. And I can imagine actually there being a, not just, of course, TLS protecting that, but there being a login required for that. Basically, you need to be able to prove that you're the right target for a call from that number before you can access any passports from it. And since STIR has, again, this property that there are security instruments that verification services have been issued, I should say that authentication services have been issued, that let them prove their authority for numbers, assuming the AS and VS are basically implemented by the same entity, I can imagine a VS using its AS credentials to say, actually, I am the right target for this, and nobody else should be able to get it other than me. That alone might not be sufficient, which is why we're also looking at things like using some kind of hash, where the index in which passport objects are stored at the CPS is not just something like the originating number, but is more like a hash of the originating and terminating number. But even that probably isn't sufficient, because you could just do an offline process to calculate all those hashes for the entire North American numbering plan, and just, or even if you just had a particular target. Like, let's say I wanted to monitor, like when Lady Gaga calls Madonna, right? I know both their phone numbers. I can calculate that hash, and then I can go interrogate the system for it repeatedly. So you need, when you talk about the CPS design question, to have a set of qualities for that. Like, you need some kind of polling prevention for single targets that's going to prevent exactly the attack I just described, where you know that somebody might want to ask, okay, is Lady Gaga calling Madonna right now? Well, is it right now? Well, is it right now? Certainly you can design these things in such a way that can prevent that specific kind of attack. What we can't do, and the limit of the design, is we can't implement some kind of nonce that we think is going to be carried end to end. Because if we could do that, we could just carry the passport, right? I mean, we need to assume there is a discontinuity between, in the internet connection between the originating and terminating side, and that we need to just be able to rely. We only have these three factors: the originating number, the destination number, and the timestamp. Those are the only things we can use to try to provide the properties that we want from this. Well, and we have the security. We know that we have cryptographic instruments that let you prove that you are the right authority for a set of numbers. Those are the moving pieces. And we can talk about what the right way is to combine those and the best way to try to beat these per pass attacks. Definitely agreed. That is the challenge of this work. And it's the work we need to do.
Henning, I think a useful way of framing the design requirement, and maybe in the draft as well, is that from a privacy perspective, is that the same entity that can already get information should be, we should be no more, no less strict than the entities that currently already have access to call detail records,
Yep.
which includes the originating carrier, any intermediate carriers, and obviously the endpoints, as well as for terminating carriers. Those entities could be half a dozen, already have access to all of that information. They know exactly when Lady Gaga called and was called. And so protecting it beyond that is pointless, because assuming the security of the CPS isn't any worse than the call detail record security, then you don't have a problem, and you don't. So the central point that I think you made is the originator already knows all of that information without asking, so protecting it is pointless. And the terminator needs to get access, doesn't know it. So if you authenticate the terminating entity in a way which is equally strong, and if you use the same trust relationship, namely that the terminating entity has to have a trust relationship with their carrier, because they already know it's call detail records, so they certainly have to trust them. If they don't know anybody else, they don't know who the originating carrier is. So to the extent that we can make the CPS logically be associated with a terminating carrier, then I think we have a reasonable chance of making it work, even outside of a certificate for the terminating entity, simply because if that gets deposited into the terminating carrier CPS, it's already a customer, it presumably already has a login to a website to that entity. It can get an OAuth token, whatever else you want.
Yep.
You have now a range of authentication mechanism, which you can make as strong or as weak as you desire. And you can make it individual or corporate. In a sense, you can have this be a corporate token for any call arriving at an entity as opposed to an individual one. And that, I think, gets you there. So then that transforms the problem for that particular model. I'm not saying that's the only one.
Yeah.
It transforms a model, which I think is the simplest to explain to people, is the originating entity has to find the terminating carrier, so that can know which CPS to deposit this information into. But we know how to do that, generally speaking.
If we could
in
do
phone
that,
network.
though, Henning, we could do SIP.
I'm sorry?
If we could do that, we could do end-to-end SIP, right?
Well, I'm going to speak to that. So
Yeah, I mean, I think that problem, that I totally agree with that. It's a much more tractable problem, the problem I'm proposing. But I think that problem is identical to just doing end-to-end SIP, right?
No.
It's not.
It's the originating carrier has to find the terminating carrier. Then yeah, it's the same as
No,
you send a
no,
register.
generally
right?
speaking, the limited portability database will tell you some pretty good approximation. I mean, I'm saying they're corner cases, but it gives you an approximation of a terminating carrier or an entity that is in a direct contractual relationship with a terminating carrier. So I may have a SIP trunking service that isn't allowed to get their own numbers, so they get their numbers through some third-party entity, but it is bandwidth and level 3 and whoever else that actually is the number holder of record of the terminating number. And so it's at least a one layer removed, practically speaking, trust relationship with the terminating entity.
So I know Robert really wants to talk, so I want to give it to Robert, but I'm going to say real quick before Robert talks that I think the use of the certificates we have for STIR to be able to prove that you have this authority for the number can take the place of the trust relationship that you just described and allow the CPS to be decoupled from the administration of either the originating or terminating carrier. That is one of the models here that I think is worth considering. We'll talk about it, but let's let Robert. lower talk.
Mainly because if that information at I mean, because you made a point, which I wanted to be able to respond to, is the point being that if the information in the CPS is valuable in and of its own, meaning if I can compromise the CPS, I get access to the database as a whole, I have a problem.
Obviously, though, if we have these credential shares, they can be encrypted then, right?
Right, but if you said earlier, if the passport certificate has either a number or a hash in the number, which essentially, given the finite namespace,
no, it would be indexed at the CPS by the hash. That's different from saying that the passport is going to contain the hash. So the passport could be encrypted under a hash that is opaque, right? At least relatively opaque. And if you allow that there are credentials that let you attest ownership of a number, those credentials could be used for encryption purposes for this as well. That is one aspect of the design space that we explore for this anyway. But Robert, sorry, I can tell you're curious about this. Yes.
Can you back up to the slide where you're showing use cases? That's a good one right there. You have put out as a fundamental premise that we would only want to use the CPS when there was no direct internet connection between the endpoints. And I think that that's flawed.
Okay.
I think you may have some reason to gateway to some other protocol that can't carry the information, even if you have a internet pathway between those two gateways.
I'm sorry. No, I said that as well. I said that there could be IP, there could be any that are merely stripping identity headers, and that is a problem with this. Yes.
Right. So in those situations, that CPS thing could become treated as a logical role as we're exploring the design space. It could live at one of those endpoints, could live in one of those endpoints, and the kind of end-to-end secure transporting kind of stuff that Eric was talking about could be applied to ensure that the gateways weren't having a third party monitoring what was happening inside that CPS. It's a unique use case. It's probably an edge thing that we won't encounter much in the wild, but we should be careful as we're exploring the architectural space to not preclude deploying it that way.
I agree. Yes, logically, the pieces should align such that that is a possible implementation of this. Yes.
Jonathan Max, I mean, I think generally speaking, I mean, your assumption always here is that the signer and the verifier both have internet access.
It is, yes.
So I'm not sure in that case why the CPS needs to hold the passport at all, as opposed to just being a rendezvous service, at which point, the CPS is forwarded, between the two endpoints. And I think that's what Eric was getting at.
I mean, I think, again, it's cases like these ones, right, where there's hybridization and things like that. And again, I'm looking for something that's going to give us a general framework that would work just as well for like XMPP to SIP, right?
Right. I take your point, but I guess, and maybe you could say that, I don't know. I mean, just trying to minimize the amount of information that the CPS ends up having. So maybe it just says, oh, hey, here's the rendezvous point by which where you can talk to the person who has the information you need, rather, and with an additional level of direction, rather than being a big database of every call on the internet. I mean,
it's also the case, right? Certainly that these records be encrypted at the CPS, I imagine will be a part of the eventual design space of this. I guess it is a tacit design principle of this. I'm not trying to create a back channel that will let you negotiate SIP or something else like over the internet against the wishes of the things in the middle of this, just to convey the passport. And I think that has, the passport is not going to give you M lines, right? Yeah. I mean, I think that's the thing I'm trying to avoid in this, is to get to something that is basically isomorphic to, I'm storing an invite up in, some service. And I think anything that's just a pointer to, by the way, here's the other endpoint of the call, go talk to it directly over the internet, is a way that you're just going to then set up an IP call, right?
Is that a bad thing?
I know.
I mean, it's frequently the case that maybe I don't have, I think there's many use cases where I don't have the I don't have the bandwidth for an actual voice call or whatever, but I have the bandwidth to pass a 1,000-byte blob of data around.
Think about. I don't think do I have this one? No. I say if I had one that had just the gateway. No, I guess this I can do it with this one.
Yeah.
In this case, it is a POTS call that's come in, so your iPhone or something here on the right-hand side. In this case, okay, if we had a rendezvous function, you could set up a SIP call and drop the POTS.
I don't want to set up a SIP call. presumably I'm doing the audio over POTS for a reason.
Yes,
You know,
exactly.
I don't know if it's a good reason, but I'm doing it for a reason.
Exactly.
But that doesn't mean that I guess that doesn't mean that the information passing model has to be, you know, has to be like storage and retrieval,
It doesn't.
as opposed to, you know, rendezvous and then, you know, a lower bandwidth but still
Definitely
end-to-end.
agreed that what
or-
could be stored at the CPS could be a pointer to a place that you could get the passport object. If that's what you're saying, logically, that is not any different from
Okay.
the way the
all he's saying.
Yeah.
Okay. Okay, sorry.
That's what I was trying to say too.
Yeah, so obviously that clarifies that conversation, but I think that then comes up to so what information do we use to access this pointer?
Right.
And we get back to the same conversation we're having about, you know, the from, the to, and the time is
Yeah,
all
so
we
that's
got.
all you got. Yeah.
and we'll end up revealing all of that to the CPS in some form or another, which is the design problem we want to approach. And it may turn out to be the same as the passport, so the pointer didn't buy you anything. And I was also just going to speak to, you know, experience with deploying Viper, of that. Actually, lots of times people have a perfectly workable IP path and they really have zero interest in using it. They want to go use the PSTN for a series of reasons, which may or may not make sense, but largely go to it works and we see no advantage of switching.
Yeah.
So I think there are lots of cases where you may have full end-to-end IP connectivity and no interest in using it. And I think it's an important problem for us to solve.
Relaying for Dave Crocker. If there is a standardized naming of the actors, there needn't even be a rendezvous function, since the passport could be stored in the DNS under that domain name.
Yep. So storing it in the DNS, storing it in DHCs, like all these things that I don't think anything is necessarily off the table in terms of how it gets stored, where it gets stored. Probably in the DNS, it would be to pointers, again, unless it's encrypted blobs that are in the DNS. And as well, we expect these things are very short-lived, in the sense of, you know, we want them to be there just for the duration of the call is alerting, pretty much, and be removed when the call is no longer alerting. I'm not sure if that's the best fit for the DNS as well, but
Yeah, I mean, surely there's some variant of this where CPS is spelled DNS.
Yeah.
I mean, it seems like there are two questions, right? One is something like this valuable? Stipulating we can build it.
Right.
Is something like this valuable? And I think the answer, I'm at least convinced the answer is yes. Otherwise, I wouldn't have spent any time on it. You know, if I could figure out some way to tunnel this crap in PSTN, obviously I would do so. You know, I mean, I know I've come to you about 18 different ways to try to do that, and you told me none of them will work, and I believe you since you know this. It's just better than I do. The second question, of course, is it implementable in a way that's acceptable? That seems like still a little more open question. You know, I think I'm responsible for this design, but I'm not very satisfied with it. So I think that's the purpose. I mean, you know, there are different kinds of IETF working groups, and some IETF working groups, like basically you have the solution and you write it down. And some IETF working groups, you're asking for the collective wisdom of the community to like actually figure out something to work. I mean, this is a little more the latter case, and we have something which might just be barely acceptable, but perhaps you can do better, and might at the end be unacceptable, and we should be exploring. That's the point of exploring this in a working group.
Yeah. And I mean, that's pretty much what I'm going to say. I mean, this is already on the charter. We have a milestone to do something like this, right? This is the best stuff we've been able to come up with so far. We are not saying that we got this licked, though. We're saying let's do some work, right? We see the stuff on 4474 BIS wrapping up. You know, given that does wrap up in the next couple of weeks, and we expect that it will, I think we would have some cycles available here, and we would propose to like have a virtual interim or something like that. The key point I make at the bottom, though, is that and you know, there are people who participated in the FCC robocalling strike force here, and I won't speak for them. They can speak to what went on there. You know, I have heard anyway that there were people talking about, well, what's kind of the PSTN story for all this? And like, you know, I think we have part of the PSTN story and the work that's being done in ATIS. I think this is a story that might allow us to get a few more endpoints participating in the STAR ecosystem overall that might not otherwise, again, looking at things like IPv4s, some other kinds of smart yes. And maybe that's something that wasn't adequately described here when it said what the service discovery mechanisms are. Provided it has this property that the originating and terminating side will arrive at exactly the same conclusion, again, just based on the 3 factors, right?
Yes.
Originating, terminating, and timestamp. Provided that's true, there is no requirement that any of this be centralized that's built into this. We're talking about a totally logical picture of that.
Yep.
So yeah, I definitely have no problem with that.
Colin again. I also think that we have lots of IP networks all the way where there's so many things you have to traverse in the IT model that it's a much easier deployment model that even if it's all inside your network, you sort of, deal with it on one edge and deal with it on the other edge and sort of duct tape both sides and not try and upgrade every single thing across the middle of your path, even if it's an all IP network, right? So,
Yeah.
you can support all these models. It's a lot of use cases.
Yeah, I guess one thing I do want to mention is that, I think that storing this on the endpoint strikes me as not likely to work very well, given that I feel like given that it's been the past 5 years trying to connect up endpoint A to endpoint B, and every single time I need them to do that in the middle for them to talk to each other, it's really hard to understand how I'm going to get away without that, suddenly solve this problem. So, yeah, I think that as I say, there may be n different ways to spell CPS, but it's going to be up in the cloud somehow.
And maybe what's up in the cloud is just a pointer, right, that goes down to some entity where the passport is stored. But yeah, there has to be some kind of rendezvous. Again, if we only have these 3 factors, and we need entities without pre-association to somehow arrive at the same answer to the question of where I go get this, there needs to be something at least that gives you a pointer that's in the middle.
Again, Hank speaking. We have 3 pieces of information, but we also have existing databases.
Yep.
Some of which were run by the company that you work for and others that allow us to do some of that mapping already. And so I don't think we should, because we are largely, not exclusively, for all the reasons I just mentioned, we can rely on some external infrastructure that will most likely, at least in some of the cases that are of practical interest, that we can rely on, that we know more than just the plain numbers, as in we know something who actually, which carrier owns each of one of these numbers, for example, with high probability. I mean, not perfectly because of some of the delegation issues, but as long as that entity has a way to be identified and can be induced to play along in some way, we actually have a little bit more than just 3 strings or numbers.
Yep. And I definitely do assume the security associations behind the certs that are used to sign passports, things like that, so on, are also points we can use in this. We're probably good for time.
Well, we are, if you make your transition to your next subject now.
I'm on next subject, and I don't have any ask today about this other than that, don't be surprised if there's a virtual interim that is held for this sometime next year. Read it. Tell me what you think. No, I think it's interesting. Next slides. We have a charter milestone for it, so we're going to be talking at the charter at the end. We can talk about what we want to do about it. Passport extensions. Right. So we've changed Passport and RC 4470 bis, 4474 bis a lot in the last 4 months. And one of the things that we've repeatedly changed has been the extensibility model, just as we've tried to understand what the meaning of PPT was, whether we wanted to have alternate MIME types is one thing we talked about a lot. Should we have application passport plus some separate typing for that? Can you just throw extra claims into a baseline object, or do you need some capability negotiation in order to do that? We really danced around this. And what we ultimately ended up with is just 2 extensibility models for Passport. And I want to talk about them a bit in light of 2 documents that I submitted for this time that try to exercise the extensibility model a bit, and also refer obliquely to a 3rd one that's over in SIP Brandy. But the main purpose of this actually is to make sure we got it right, to make sure people understand what the extensibility model is, because this is pretty much our last chance to fix it if it turns out it doesn't actually work, since these documents are in IESG review. And I thought probably the best way to ascertain that would be to actually try to extend it, to put some things out there and see if it looked like they did an interesting job. So the two mechanisms come down to things I just described. In one instance, you could have a passport object that doesn't have any new information in the header, but merely has additional claims added to the claims object. This is something that JWT baseline allows, and we just devolved to the JWT extensibility mechanism for that. If you want to go define some new claims, you go do it through JWT's extensibility mechanism, get them in the IANA registry, and then you'll just be able to use them. And if you're a relying party, you need to use what we call the full form of Passport. You cannot use the compact form when you extend in this fashion. You end up just kind of looking at those claims, and if you can use them, great. If you can't, no worries. They're all just kind of optional. That's the way we treated that dimension of the extensibility model of Passport. And then we have PPT. And PPT is short for passport type. This is something that will appear in the header. There'll be a new element. It'll have some value to it. Those values are in a passport types IANA registry, which you just need to do a spec for, and you can get new values for it. When you put that in, you can generally still use the compact form of Passport, because that spec that is pointed to by PPT will tell you what the new claims are, if any, that are being added. Any way you're changing the baseline rules of Passport will be described in that. Anything different you would need to do as a verification service based on receiving something with these claims. And it's mandatory. In other words, if you don't understand that PPT value, this isn't something you can just be like, well, I can get the rest of the object. No. If PPT is there, what that means is you've got to support it, or you ignore the identity header that it contains. Those are the two models. What's that? Jonathan, you have something?
Confused by your slide because it looks like your descriptions of the two things are identical. Am I missing something here?
Oh, geez, you're right. Actually, you're entirely right. That is, wow. I should really read these slides before I send them in. Yeah, we'll have it be right, I think, when we actually go into the examples here. So, well, good. Somebody reads these slides as I'm up here talking. It's really remarkable.
Pay attention to what you're saying.
Yeah.
The slides to figure out what you said.
As I drone on and on, you actually read the slides instead of listening to me. So anyway, yeah, let's figure out if this actually works or not. I have two little trial balloons we can float, one for CNA and one for div that we're going to talk about. CNA is short for CNAM. This is actually a draft that Chris and I submitted a while ago as kind of a way you could try to do display name within SIP. This is when people are still using the acronym CNET a bit here in the IETF, and there was some notion we might want to have a working group that was looking at this problem in particular. And the idea of that is basically it'll have a display name captured in a sub-element of this CNA element of the claims. And this is something that can be used with or without a passport type indicator, interestingly enough, and you'll see me talk about both versions of that. And we also added something for diversion information. We're going to talk about that first. And this is something we have a long history with in SIP. The notion that when you send a SIP call somewhere, it can get retargeted, redirected to somewhere else. And wouldn't it be great if we had some indication in SIP that let us know why that had happened? Now, of course, there's been a lot of work on this over the years. There is famously the version header, which I think maybe we did like diversion as a historic RFC eventually, just to let people know. Yeah, I think it was an ID that we didn't.
After being published on Cisco's website for 10 years and refreshed every once in a while by someone who hated it with a passion, we finally got it off my plate.
Right.
Yeah.
So there is an RFC though that describes its behavior, even though it is not a standard. And then of course there's Mary's work on history info for this as well. The interesting component of looking at this for Passport has this interesting dependency, right? Because you specify an origination and a destination element when you generate a passport as an authentication service. And it's kind of important that when you get this, the dest makes sense to you. Like if you're a relying party and you get a passport and you intended to call when I created it, I was going to call Martin. And in fact, the person who receives it is, Krister. And Krister looks at it and sees in the dest field, this says this is for Martin. Well, one of two things has happened. Either, Martin had call forwarding that sent this call to Krister, or potentially I captured, some evil person captured this passport object in transit and is replaying it, right, to Krister. And how can Krister actually tell the difference between those two conditions in this instance? there are a lot, and I think history info and things like this were intended to be able to capture the reasons why these redirections occurred and to be able to have a chain of them. For the purposes of extensions like SIP Brandy, though, where we actually want relying parties to have a stronger cryptographic assurance of should this call have been to me or not, because your purpose is to establish end-to-end media confidentiality. Having a cryptographically assured way to note that a diversion occurred seems like it would be valuable. This also, when we talk about the fallback mechanism, has salience to that as well. Because remember, the only 3 indications that you have, right, are the originating number, the terminating number, and the timestamp. And if the authentication service that provisions a passport up to a CPS in the first place had an original destination, my destination was Martin, but then it gets redirected to Krister. When Krister gets this call on the PSTN, Krister will interrogate the CPS and say, for my number, Krister's number, and the originating number and the timestamp, do you have anything? And maybe the answer is no. Because in fact, the original passport was for Martin. And so what this would allow us to do is to create passport objects that could be either in identity headers or in the CPS that would close those links in the chain. In other words, when Krister, if we had this div object in the CPS, went and looked at the CPS, he would say, oh, well, for my number and for the originating number and the timestamp, do you have anything? It would say, yes, it would be one of these that actually has a div object in it. And we look at a div object, it'll have what the first target was specified among the claims, and that will rely back to what the original passport had specified as the first target in its dest. But this will let you have this assurance that you then need to go look for the original passport in the CPS or in a separate identity header to establish the links in the chain. I see people whose faces are screwed up, but they're still nodding. Are there people who are looking at this that like, I don't get it, I don't get why this works? I think people get why it works. Mary, do you want to talk about it? Krister, do you want to talk about it? Krister, I even used you as an example. How could this be unclear? Sorry.
No, I haven't read the draft, but just a generic question based on the history of history info.
Yeah.
A lot of discussions we've had with history info is this a retarget? Is this diversion? Blah blah blah. Does the target change, etc., etc.? Do you think we could end up having those kind of semantical questions about this? What could you use this both for retarget and just for rerouting, and do we need to differentiate it and those kind of things?
So an interesting quality of this that's also different from history info and from previous retargeting is our canonicalization properties of passport. So in other words, when you look at, if you imagine that the destination was a number, a telephone number, right, rather than a URI in this case, or even if you imagine it was a URI that originally had like tons of parameters and stuff like that, a lot of those little things that just change the syntax of the URI but not the destination, they're eliminated by the canonicalization pass of passport already. So in other words, if this is to a telephone number and originally it's at AT&T.com, but then it gets switched to, Verizon.com, right? But it's still the same telephone number. You don't need a new passport for that. That's one interesting distinction from the ways that this previously worked in things like history info. And it just falls out of the fact that we do this canonicalization pass before we put the identifiers into the passport already. Mary?
Mary Barnes. So, I mean, I see what you are trying to do, but I need to think about it some more, but
Oh, it's brand new. And again, I'm not even here to tell you that this is a baked proposal yet. I'm here to tell you, here's an example of how we extend passport. Right? Okay. I have 2 examples of how to extend passport. I want to make sure we get the passport extensibility model right.
Okay. Well, then that's fine. I can see how this can work. My concern is that you're getting a lot of stuff that's duplicate in there, right? And is there another way to?
Well, and remember as well that the interesting.
I think Mary is talking about history info, but this could mirror the history info, right?
So you could look at this like the same way the passport signs things that are elsewhere in a SIP request. Literally, this could, what is in that, div field there is in fact what would be in a history info field, right? So, this is merely providing the cryptographic assurance because sometimes you need that. Like I said, these weird cases like just like SIP Brandy or like we were going to do this as fallback where you don't have the benefit of access to the rest of the SIP signaling even. Those cases I think are really interesting for this. And I think the baseline cases as well, if you want to have something, and we talked about signing history info back in the day, periodically.
Well, this is why
we decided not to. right? For
We
a couple
did
reasons.
because it was too hard then.
Yes.
So
think
the
with this,
question is,
though-
we have tools now.
Right,
that-
exactly.
And we need, I'm just not sure this is, I have to think about it some more. But I mean, I do see what you're doing here.
Yeah,
And this makes
this-
sense from
right.
what you're saying. I just don't know if it's
This is a
optimal.
direction. This is a 0-0. If we were to have a charter discussion at the end of this, which I hope we will, this is an example of the kind of thing we might choose to take on. And in so taking it on, then we do work, right? This is not done. Yes, sir.
Alan Ford, I appreciate this is an example, but if we were to do this, it's a bit confusing having a single domain in this. So let's say destination was example 2. The original destination was example2.com. The div was also to example2.com. Would example2.com be signing the div PPT,
Right.
and then the originator would be, you'd have 2 identity headers,
Yes,
one
that's right.
signed by,
So this is a quality, and I kind of skipped over the slide to get the examples hastily. The interesting quality of the way div works is, yes, it is signed with the credential for the original destination rather than for the originator.
original destination, yep.
Yeah.
Okay.
And
yeah.
so, yes, you have to pass through the chain that way. But since this is a point about the extensibility model, the extensibility model with PPT, as long as it's mandatory, lets us say that we're going to change the rules for how the SIG works. So in this case, the SIG goes over for these specific passports, the destination instead of the origination.
And you'd see 2 identity headers for this. Yeah.
You would. You'd need to have the one identity header that would wrap back. So in that sense, it would look a lot like History Info did, right? Except you wouldn't need every transformation because, again, of the canonicalization things. Yeah.
This seems like it would work. Yeah.
I think it will work. I mean, it's different than what History Info does, again, because of the canonicalization and because it's not trying to capture like reasons or stuff. We could add like, again, once you have an extension, you can create a bucket that could have like reasons in it if we wanted it. But the important thing for me is, again, to get that cryptographic property to reassign the way the signature is being used and to be able to hit, at least capture what the original targets were. Yes, Chris.
When I was just thinking maybe when you mentioned the out of band thing that might have confused things, because I think as you go hop to hop diversion, you would be adding something to the history info and an identity header, right? Just to make that clear. If,
Yeah,
for in-band,
For in-band, you would, yes.
Yes.
Yes. For in-band, you would.
So, but it would work differently, I guess you're suggesting in out of band.
In out-of-band, it would work.
Yeah.
Well, in out-of-band, again, you can't assume end-to-end SIP
Right.
goes
It
at
might
all,
not be
right?
SIP, so
And-
there's no history of, right.
But the important point is, again, if you have history info, then again, it's easy for you to walk back the chain and ask, should this call have been sent to me? Now, again, plus or minus the cryptographic stuff, right? Because
Right.
you kind of have to trust that those
But
history
but
infos
for
were all.
in-band, it would be straightforward. You're adding history info, information, and a corresponding identity header for each.
It wouldn't necessarily be for each, though, again, because of this subtle distinction that the canonicalization system eliminates a lot of like the really minor changes that you send. So the problem is history info makes, new entries if you even change like the domain that a telephone number is associated with, where we would canonicalize that out. Because if all we cared about is the telephone number, it doesn't matter that you change other facts about the URI along the way.
But you would have this div.
Yes.
You would have this div PPT, right? So you'd have
Yep.
the original identity
Yep.
header, which is bare minimum. You'd have another
Or
one.
not, right. It doesn't have to be the bare minimum, is my point. Sorry. It could be,
Right.
you would have a huge
Could be
one. right?
whatever,
Yeah, it
yes.
could be whatever.
But in the simple case.
Right.
And then the next one would be this div object, which would include orig, dest, and
Yep.
div. And then if you diverted another time,
Yep.
you'd have another. Okay.
Exactly right.
But what's the canonical?
So the difference is that the subtlety I'm bringing up, and this has to do with the way that diversion and history info, what they consider to be a change. So for example,
Right,
consider
okay.
a URI
Yes, okay.
that's,
I see what you're saying.
yeah, okay.
Got
There are things canonicalization would eliminate that would be changes that would be tracked by history info. So there'd be fewer of these too. It would actually, because of the canonicalization, it wouldn't go through some of the transformations that you cared about in that. But again, I'm just trying to show right now, I hope people think this is interesting as an example, but trying to show this is how the extensibility model would work, and this is the properties that we think it would have in these cases. We also have the CNAM thing, and I wanted to show this one in particular because it operates in 2 modes. One mode it operates in is one where the originating side signs the originating authentication service. So if you are Comcast and you know the subscriber's name and you just want to add that to the bare minimum and to let that travel end to end under the same integrity protection as the rest of the passport object, you just can, right? That's just another, JWT claim that you add and you're done. You could also do it, though, in such a way that you wanted to, again, shift that rule. So it doesn't have to be the entity that originally signed for the originating number. that knows how to transform that number into a name. So an entity that has a third-party CNAME service, I can't imagine who in the world would operate such a thing as a third-party CNAME service. They do exist. That entity would then use something like the PPT field to communicate in a passport object. I know I'm not the entity that is authoritative for the telephone number in question, but if you trust me for some unrelated reason, here's what I think the display name is.
Jonathan Lennox. I mean, on the first one, I mean, it seems like there have to be something like in the root cert saying I'm willing to sign CNAMs, because if I get a cert for my phone number and I prove to everybody's satisfaction on my phone number, and then send you a passport saying John Peterson, that's clearly bad.
We can talk about that a bit. So we do imagine that proof of possession certs, and we're going to talk about proof of possession certs in a minute, have a different LOA, right? Or at least this is something that we've discussed a couple times. We need to do some more work on this. But that core idea that those certs are going to have a different situation and different powers is something that we're already kind of baking.
Yeah, but I mean, or even if Verizon hands me a cert, decides that they're going to give my cell phone the cert saying I own this phone number, but and then I sign the call, but also say John Peterson. So there need to be something in the certs somewhere that says yes, you're allowed to sign CNAMs probably.
So if you look at STIR certs, what Russ implemented in it, there is a JWT claims constraint that you can do in the cert. And what this lets you do is literally say things exactly like this. If this claim is going to appear in passport and and it's signed for this, it's going to have this value. And if it doesn't, then don't accept it. So I mean, there's a general capability, and thank you very much, Russ, for designing that for us. That does exactly that. That's in STIR certs today. And so yeah, I mean, these are examples of what it would look like. I don't know why they're so poorly formatted, but this would look like without PPT, where you just add something like a CNA with the CNAM for Alice Atlanta. It would look like with. No real difference other than that you see the PPT header there. One of the reasons why we structure this, you can see CNA as its own array in the way that this is defined, is because we want it to be extensible to other kinds of things you might want to be able to associate that are aligned with it. Henning, when I looked at your call info stuff, I thought this is an example of something where you could put in confidence or related factors like that could just fall into that same array. In other words, this is a place we could slot in if we wanted to have a signature over the parameters that you were identifying in your document. This would be one easy thing to just plug them into. And location and other things like that are frequently discussed as things that would be useful to give along with the display name.
Alan Ford again. If the receiver couldn't validate one of these additional elements you put in, is that purely up to local policy what they do with it, or would they fail?
So my general answer to everything in STIR is it's up to local policy what they do with it if they don't understand it.
So if a initiator wanted to ensure it validated or the core failed, they'd also have to define a new PPT for that, presumably.
So we haven't talked. So again, the draft's really sketch today. If the fields under CNA, like name, or if we want to add location as a field or something under CNA, needed to have that quality of being optional or mandatory, we could create a mechanism that does that. That array is going to be under our own registry, and it'll have its own. If we pursue this, it'll have its own potentially capability negotiation qualities.
Mean in the JWT definition rather than the PPT definition?
No, it would be in the PPT definition. So the JWT definition will say, in this instance, right, if the PPT is present there with CNA, that means you have to understand CNA or you ignore the identity header. The question of, well, within the CNA, if there's something other than NAM that appears, like lock, say, for a location, and I don't support that. There's no provision today for us to say, well, you need to fail if you don't understand lock. But because the stuff that fills that CNA element would be defined in the specification or in its registry, it could have its own capability negotiation like this that we could build into it. I certainly have not even begun to sketch that. This is just intending to convey what this could look like at a high level. But
that's purely in the case where you've defined a new PPT.
Well, we've already defined a new PPT,
Yeah. Well, I mean, it's the ability to do this negotiation is only the PPT case. If you don't specify a PPT, then it's purely local policy.
It is, yes.
Yep. Okay, great.
Yeah, because we want this to be kind of freewheeling extensibility for cases where things are just optional, right? We want you to just be able to, there's things you want to throw into the claims of the JWT object. You know, we want to be able to say, feel free. We got a lot of pushback early on not to make the extensibility model for this too strict. And so we've tried to keep it really open in that regard, to just let people use things like that with in as lightweight a way as possible.
John, you're probably going to want to go fast.
Okay, okay. I mean, really, I have to say that these are just examples. I think they're interesting. We have the charter discussion. We'll talk about whether we think we should have a charter bucket for doing some extensions. But I hope that looking at these, the extensibility model, and Alan, your question is exactly the kind of question I hope to get here. Does this make sense? Are we doing it right? You know, if not, this would be the time to fix it.
So this is really a nitpicky type thing, but one of the ones I wonder about is for reducing general confusion. Using the term CNUM itself, I think is somewhat unfortunate because it implies really two things, namely a name and that, and obviously you're labeling a whole bunch of other stuff which has nothing to do with today's CNUM, and a particular mechanism, namely a database that does the lookup. So I would wonder if what you're doing here is really, it is in some sense the moral equivalent of one aspect of CNUM, but it is not subject to the same restrictions. It's not even subject to the same database. I mean, it probably doesn't originate in the same database, all of that. So I would just it already gets confusing for people to differentiate kind of third-party database dip type of information with multiple versions of that floating around, where what you see and what I see for the same call may not be the same thing.
Sure.
To in-band information, which is in the SIP call headers and that, which is what you're doing here. So I would, and again, just so that we know what we're talking about, is even though, yes, it is kind of like it would probably replace CNUM at some point in some cases, but it is not CNUM.
We can call it CNET as long as people don't think that name is
but it is something else. It is caller. It is additional comment. It is call info largely, plus the display name. I mean, that's really what you're talking about. But it essentially is call info type of information.
A secure call info, yeah. Yep. Anybody else want to comment on the general extensibility model or the probity of exploring things like this? Christer?
Christer, I guess there could be a case where you have in the same passport, you have multiple PPT values if there is a future use case where someone wants to put a lot of stuff. I don't know if the two examples that you have shown here could be combined, but I guess in future you could have diversion or this together with something else.
So it's interesting. Div, I think, would never be together with something else.
But
like
something. I mean,
So I think our party line of that, and this is a fact about the extensibility model, has been, no, you do new identity headers. If you're going to have two mandatory things that are expressed to it, you'll need to create two identity headers for them. And again, once you admit multiple identity headers, I think the hit of that isn't that bad, especially because you can use compact form. And the alternatives, as I started looking at them, again, we explored this a bit of doing like CNA plus, they start to look really bad. I think it's clear in the spec. Well, I hope so. Tell me if it's not, right? I mean, this is our last chance. So yes, Alan.
So just another quick point. If you had to do this with multiple identity headers, then someone could remove one of those identity headers and you'd be none the wiser on the path.
They always can, yep.
But
they could always remove the baseline identity header, right? They can't do anything about it.
Indeed, but if you're trying to add new useful information like CNA into this, and also you had to do something else, and then someone slipped out of CNA and then was able to edit the called name, and it was never
no one can edit the called name, right? Again, this is a question of whether you have an integrity protected blob of text there or not. They can remove the blob.
I didn't think it through.
These things can't defend themselves. I mean, I can't help with that. Yes, Chris.
I think in practical deployments, you're probably going to come up with either a PPT yourself or just convention of I'm adding certain claims. So
I think so, yeah.
People, I don't think will have 12 identity headers just for the heck of it.
I hope not.
So I mean, I do think it's unwise to try to have multiple identity headers protect each other. If they're all being generated by the same person, it's technically possible, but kind of gross. So I think I'd better off to have them be parallel. Like every attempt we try to make in cryptography, in like cryptographic messaging systems, like try to like have like a harmonized view of what the hell is going on. I think in these things is kind of failed. Rust may think differently, but I think.
No, we always, when there's a signature, multiple signatures, it's always, do I have to validate one? Do I have to validate the other? Do I have to validate both? And it goes on. So the more it gets, the more complexity you introduce.
Yeah.
We need to wrap this discussion up. So quickly, no one else get in. Mike line's closed. That's what I'm trying to say.
John Lex, I mean, just I think sort of to the point I was raising previously about, I think, the claim constraints, I think you need to make it clear to people who are issuing certificates that they need to think about, potential future unknown claim extensions when making their certificates, and make sure that, if this is a case where you want to make sure that, only the claims that you know about are signed, you better have claim constraints in that signature that says, I only do the baseline. This is only allowed to sign baseline. Don't try to sign some extension.
We did not define a wild card for claims. So if that's important.
I mean, we could always make these additive permissions rather than, right?
Right, but we didn't say, can't include star.
Yeah. No, but I think to Jonathan's point, I mean, if we had an additive permissions model where you required something that said you're allowed to specify.
I mean, I think you would say you're only allowed to specify, whatever the claims that you already know about as a signer.
That is there now.
Yeah, so I mean, I think, but there maybe needs to be guidance, not just, this is the syntax for it, but a guidance for people signing certificates saying, when you issue somebody a certificate, think about, this extensibility, claims you don't know about could be signed by this. If you don't want that, have a claims extension in that certificate.
Yeah,
agreed.
I mean, we still have work to do on stir certs in the next couple of weeks. So yes, I think we have room to do something like that. Yes, Chris, real quick, we got to do Acme. Go to the Acme slides.
So to me, it's the opposite problem, that you should trust the person that you're validating and know that they're sending you, like, local policy should be to ignore claims that you don't want to receive and don't understand or don't think that that person should be. So you should have some sort of relationship with the person.
The relying party as well could make determinations of how well they trust. And so that was the point of the LOA-based approach, right? So if it's like a proof of possession cert that you get, if you're a relying party, you would say, well, I don't trust anything this guy says. Hell is this guy anyway? Okay, next slide. Real quick, we're going to talk about Acme.
You have the button.
Oh, Jesus Christ. I have the button. I have the power. So yes, Acme. There exists this thing. It's called Acme. It's a working group here in the IETF. They do an automated certificate management environment. Our good friends like Richard Barnes have been doing a lot of work over in there to try to figure out good ways to do figure out, first of all, effective proofs of control for domains on the internet in order to be able to issue certificates. Secondly, to get those certificates issued in a fancy and automated and simple fashion. This has been used for the popular Let's Encrypt CA, which has issued a lot of certs, I understand, and is a pretty cool thing that's out there, doing free certs and increasing security overall on the internet. We need some way to provision certs associated with STIR. We need some way to figure out who should be able to get certs that are associated with STIR. I think Acme has this concept of proofs that actually conforms pretty well with some of the things we probably would want to do here. Today, we have some language in STIR certs about using things like EST. I don't think it's necessary for us to require any one true way in the certs document now. I guess what I'm going to propose at the end of this, more or less, is that we have an exploratory effort here in STIR to look at how we would interface with Acme for the various use cases that are interesting for us. There are also various profiles that are interested in this. I'm sure Chris could speak to what the Shaken profile interest in this might be. The SIP Brandy profile, though, that we talked about on Monday, this is something wants like end user devices to be able to get certificates. And because of that, I think that has a lot of properties in common with the ways that that Acme has looked at this to date. Anyway, it would be good to have a way of doing it, a good way of automating the enrollment of these entities that could interact with something. I don't know if it necessarily needs to look exactly like Let's Encrypt, but that has a lot of the virtues that we see in a system like Let's Encrypt today. Just to put up a picture, and I apologize to Acme people here if I'm terribly butchering what you perceive your architecture to be. You have some kind of a certificate authority. You have Acme clients. Acme clients will perform some kind of tests that will prove their effective control over the identifiers they would like to be issued certificates for, at which point they will then be able to go and request from the CA the issuance of certificates. This isn't just a one-time thing. They could have a constant relationship with them to get certificates that are associated with various identities under the scope of their control. They then use these to communicate with relying parties who can validate them from that CA. Unsurprisingly, this looks a lot like pictures I put up from STIR, not just because I'm using all the same arrows and icons and so on, but I think this maps pretty well onto the kinds of things we want to be able to do with STIR. In terms of what the interesting proofs are, STIR certs defines these two certificate extensions, well, two things under the T on auth list extension, one for SPIDs and one for TNs. We can look at what TN-based proofs might look like, both for TN ranges and for individual TNs. Some of those things would look pretty familiar from two-factor auth systems today, like SMS return reliability systems, interrogating the operating systems of devices that have been provisioned with these in some secure fashion, maybe involving SIM cards, we can talk about all the different things that might play into the proofs that will show effective control over a telephone number at that level. We can also talk about what top-down systems would look like. If you have number blocks, what kinds of entities issue number blocks, what kinds of proofs they could provide. They could give credentials that could factor into the Acme system and could allow you to acquire certificates for it. SPIDs are much the same way. There are entities out there. These are, by the way, service provider IDs for those of you who don't follow the internals of the traditional telecom network. There are entities that issue SPIDs that are authoritative for it. They could be involved in at least the authorization process that lets you get the necessary relationship with Acme for this proof. And I'm interested in this for a couple of reasons, one of which, though, as I intimated at the beginning of the meeting, is because of Stephen's discuss and concerns about OCSP. I'm real interested in the potential use of short-lived certs with Acme for this specific application, to be able to get a cert that it is basically completely opaque, that doesn't tell you anything other than I'm a cert for a single telephone number, that a provider could acquire, even if it has the authority to acquire certs for a vast number of telephone numbers for vast ranges. It might get one for only one to sign for a particular call or to keep for a day or a week or whatever, and then eventually discard. That will remove a lot of the kind of linkability concerns, a lot of the monitoring concerns that come up around this. Will also preserve some of the obscurity that service providers prefer when they're making calls on behalf of entities they're reselling for and things like that. This lets you get certs that are just down to the bare minimum that are still being used in that kind of service provider environment. So I think it's an interesting thing for us to do. If there's interest in this, I think we would continue to pursue this draft in Acme. I did send a note to the Acme list indicating this existed. There are some things we'd need to register there, and we probably define the proofs and the various identifier types and so on over in that working group, provided they're interested in taking it on. What would be left for us, though, would be to define kind of how we take STIR certs and integrate it into that Acme profile or into that Acme use case that we've defined. And I think there is kind of some STIR-specific certificate usage we would describe associated with that. And I think, it's an interesting thing to do. We don't have a ton of time, but if people would like to get up and say whether they think this is interesting, uninteresting to pursue doing Acme for STIR, this would be a good time to say so.
Mary Barnes, no, I think this is very interesting and obviously something we should pursue. Because as you know, we're already looking at this in an I task force, right?
I've heard that rumor.
Yeah, I had that rumor, yeah. So we're already trying to work out the details ourselves over there, so we should work together on this, yeah.
Definitely, yeah.
Simon Perrault, very interesting. I could see us implementing this and using it. It's
excellent.
I like this.
That's what I like to hear. I got Rich back.
Rich Sauls, I'm co-chair of the Acme group. One clarification: the certs don't have to be short-lived. That's just the way Let's Encrypt is doing it. So you could imagine, in your SIM card, there's a long-lived one embedded, and use that as a challenge. Acme's just hopefully going to be last call soon, but it is extensible, like you talked about. And I think this is really cool. And certs per phone certainly swamps what the current public CA would be doing. But there are also some other commercial CAs looking at the protocol too now.
Yep. Chris?
Yeah, I'm supportive as well. And just to add to the, IPN and I work, and we've talked about this as well, just trying to make this compatible with sort of the service provider level certs that we're starting out with and moving to telephone numbers.
Yep.
I think there's a path there, but just
I think so too. And again, I
just to
tried
note
to have
that.
that on the slide, right? That I think there are a couple steps we can take here. In the back, yeah.
Daniel McCarney, Let's Encrypt.
Yeah.
So I'm really happy to hear this. I think in the Acme working group, we've had the idea of these points of extensibility, but there hasn't been a lot of voices from other communities yet kind of saying whether these extensibility points map to their use cases. And so having a use case like this would really help with the Acme working group, I think, in terms of clarifying, whether we have the right bits and pieces for people to plug things in that aren't DNS identifiers. So I'm very supportive.
Very supportive, and I've been sort of waiting for the working group to get this point, and happy to help contribute, read, review documents, and actually do work.
Fantastic. Matt?
Eric Berger is also supportive.
Oh, great. Well, so here's the thing. We're not chartered to do this. This is whole new thinking, whole new ideas. Do we have any slides or anything, Richard? I know I didn't. So, I mean, well, here's I guess what I propose. Given that our current round of deliverables is wrapping up, we still do have out of band on the charter. We have a milestone for it. It's hopelessly out of date. So, I mean, we should probably go back with our hat in our hands to the ISG and get that corrected. But I'd also propose that we create a general charter slot for extensions. I think I proposed a couple here. If people think that extensions are interesting, I think we could maybe do those, maybe do more. I also think I would like something like this to be on the charter, that we're going to do something to explore certificate management. I don't think we even need to say it's specific to Acme at this point, but let's say something about that and propose that to the ISG as the continuing direction of the STIR working group. Thoughts?
+1 for extensions. I need to do that actually, and if we can do it in this forum, that'd be great.
We got Ben in the back and then Martin.
Ben Campbell, just a clarifying question on your proposal about an extension item in the charter for here. Would you expect work like what has been discussed in SIP Brandy and what has been discussed in Dispatch and about to be on SIP Core to actually do the extension work here?
I mean, I don't think SIP Brandy needs to be done here, so I don't want to create a constraint that any extension work must be done here. I think the work can be done in SIP Brandy on MSEC again, because in a lot of these cases, it devolves back to the JWT extensibility anyway, right? So I don't think that we want to create a process constraint. That much said, if there's a good home here for example, the stuff you were talking about, we could do it here. I mean, I just want to create a general charter bucket.
We're out of time. I have some questions I want to ask before we get out of here. Martin, can you go in 10 seconds?
Okay, if you're going to add examples in the extensibility, one for RPH for priority services would be nice to list.
You got it. I'll glad to help you with that.
I want a show of hands, people in the room that are willing to work on passport extensions and thinks this is the appropriate venue to do so. I would like a show of hands for people who want to work on integrating STIR and Acme and think that this is the appropriate venue to do so. I think that's sufficient support to show that we've got energy. We'll work out proposed charter text with the ADs and float it to the list for comment shortly after the meeting.
Thanks.
All right, we are out of time. Thank you very much. If you hadn't signed the blue sheet, please come to the front. Running to the front. We're meeting in the lamp room because I'm assuming I'm running right to the.
Oh, well, thank you. Yeah. Go.
All right. That's your gateway. That's Utica.